From there, is that okay?
Yeah, no problem. Can do.
Okay, thank you. I'll switch my own screen off. If any questions, please put in the chat.
Right, no worries. We'll make a start. So first of all, thank you for joining in, everyone. So this presentation is mainly around the TransPennine route upgrade fiber works that we've recently actually almost finished for W3. And it will cover a bit more about the project in general, a bit about the background, and sort of included a bit of the copper works and all the other operational telecoms work that we've been involved in. But in more details, I'm going to talk about the fiber works. So I want to start by introducing myself. I've not been on one of these calls before. So my name's Tanzim. I'm part of the digital technologies team at Arab. So I'm based in the Manchester office in Arab, and I'm a rail telecoms designer. So I do both operational telecoms, which deals with the line side telecoms assets, like copper, fiber, telephones, anything to do with the operational side of railway, and also the SIS designs as well, which is more of the station surveillance stuff that you see, things like CCTV, customer information points, display screens, etc. So I've joined Arab as a graduate in 2018 and been in Arab since then. So it's almost my 5th year this September in Arab. And in that time, I've joined TRU in 2020. So you can tell it's almost 3 years I've been working on TRU. Right. Next slide. So a bit of background on TRU itself. So if you're from up north or you've been up north, you've probably been on a TRU train. So I've tried putting in the route on the right-hand side here. And the section that you can see is blue, which is going from Manchester, Victoria, all the way to York. That's the upgrade works that's going on at the moment. And the aim of the project is actually to enhance capacity in the route from Manchester, Victoria to York, all the way from via Huddersfield and Leeds, so that we can introduce at least 6 fast trains within an hour based on the passenger demands. And once the project is completed, it should increase the local capacity within the network. It should also improve reliability, so it should reduce the journey times by 15 minutes within the route. We can also expect all different kinds of other services to be included with longer trains, freight trains, etc. And also improving performance as well by introducing electric trains on the route. Since it's a really big project, so it's not just Arab being involved in it, it is an alliance project. So you can see I've tried putting in most of the significant companies who are involved with the telecoms design. There are a few subcontractors as well. I didn't actually put it in. So we've got people like in Amy, Siemens, Arab, we've got Bamnatul, obviously Network Rail. So the CRE for the project that I'm working under is John Holland. He's from Siemens. We've got a very big team in Amy as well, also in Arab that we're supporting together. So it's all together. We work as a telecoms team, not just separate from different companies. So the whole project is actually geographically splitted up. So as you can see, I've put in all 3 sections. That's the works going on. So you've got the east of Leeds, the central Leeds, and then the west of Leeds. The section that we are mainly involved in, then most of the work that's been done is on the west of Leeds section. So that covers all from Manchester, Victoria, all the way to York. And even in that work package, it's been split into sub-programs. So it's called W1, W2, W3, all the way to W4. Even within them, we've got sub-packages. So I've been involved personally with W1 package, which kind of involves the area from Manchester, Victoria, all the way to Stalybridge. And then you've got W2, which kind of focuses on the Stalybridge to Guidebridge area, all the way to Diggle Junction. I'm throwing up just names, but they're just geographical viewpoints from where the project actually comes up, and they've split it into different programs. But in a nutshell, the work's pretty much the same in each of these areas. There's a lot of electrification works going on. There's a lot of track alignment works to increase the sort of buffer within coming into the stations, introducing longer trains. Also, there's a lot of re-signaling work is going on, where Telecom's heavily involved as well. There's a lot of level crossing upgrades going on. Obviously, lots of civil works and also upgrades from track circuits to axle counters, which is more efficient way of train detection systems. Right. So in terms of the telecoms deliverables in as a summary, the type of work that we've been involved in so far. So I've not been involved with the station side of telecoms, which is any sort of upgrades going in within the stations. So I know we've got massive upgrades going on some in Huddersfield. They're introducing 2 new platforms as well over there. So things like any sort of customer information screens, any passenger or voice alarm, PAVA, anything to do with help points. Those ones, we've got a separate team for that to do all the station surveillance work and the comms design. But the thing that we've mainly been involved with is the operational side of all the telecoms. So things like provision of new line side telephones, that comes in because, as I said, there's a lot of resignaling work going on. And with all the signaling changes, there's new telephones being introduced, new points phone being introduced within the route. Also, because of that, we are provisioning new copper distribution cabinets, new box on post for all those telephones and new assets to go in and connect to the network. Along with that, you have the copper cabling being introduced, new copper cabling. There's a lot of recoveries work going on as well to get rid of the legacy and the redundant copper, also fiber as well. There's a lot of lift and shift work going on because of the track alignment and new station platforms being introduced. The existing assets are being moved from one place to the other to facilitate those works. So we do the lift and shift design as well. There's a lot of modifications going on Manchester Rock. So I've used a few acronyms here. I'll try explaining as I go, but if you do get confused, drop it in the chat. I'll try explaining it a little bit more. So Manchester Rock is the route operating center, is where the entire route gets signaled and thing operated from there, the control center basically. But there's a lot of modification works going on there, on concentrator works, things like how the telephones are going to get to the signaler and how they'll be operated, all of those displays as well. And also on the transmission side, there's a lot of rerouting going on via FTN. So FTN is basically Network Rail's own private network, which is the fixed telecoms network. And there's a lot of enhancements going on in the network for the existing network to upgrade. We call it FTNX. So with that in the Manchester Rock area, we are rerouting some of the signals from the existing control center, which is in Manchester East, to Manchester Rock. This is due to a lot of immunization work on that area and electrification as well. And as I mentioned, there's a lot of redundant stuff that will be there after the project is finished. So all the recoveries design as well, we do it for the track side. And I've tried putting in a few screenshots of some of the copper design that we've done. This presentation is mainly around fiber, but it's just to give you sort of like a flavor of what we do. So things like on the top right-hand corner, I've tried putting in a screenshot of a cabinet design of an existing cabinet. So anything that's in red in the drawing, obviously that's new, trying to put in new telephones on an existing cabinet, new copper cables going in, or modifications within those copper cable. In the middle, I've put in sort of like a plan view of one of the FTN nodes. So it's where one of the core connection points from where the networks actually get distributed. So the rack designs, we do them as well. The mainframe distribution where the new copper comes in, we do all the allocations there as well and connect it to the transmission cabinet from there. And also network termination points. So for other disciplines to come in and connect to the network, like signaling, or you've got ENP to come in and connect. So they come in, connect on one side, for example, on the bottom right-hand corner, you can see there's a network termination point for telecoms and ENP. So ENP would come and connect their circuits on one side, and we would take it from the other into the transmission. It's more like a demarcation point, so we do that design as well. So I've tried putting in for W1 and W2A, which is covering mainly the areas from Manchester Victoria to Stalybridge and from Stalybridge to Guidebridge and Diggle Junction. So this is like an overview for the proposed works that we finished off for W1 and W2A. Most of it is actually been built already. So all these black lines here, they're mainly fiber on the ground. So you can see there's lots of different fibers I've tried putting in. there's two 432 fibers as well, so that's the number of fiber in that cable. So majority of the telecom services go through a 24 fiber, sometimes on a 48. And these dots here are fiber joints in the ground. Most of these are existing fiber joints. All of them have a chainage, meterage for them, and the new ones obviously are in red. And we've also introduced new sites as well to accommodate the new sort of FTNX, the enhanced network, and also make it ready for ETCS, which is the European Train Control System, to come in later. The new ones are obviously the new sites going in, and then these red cables are connecting fiber to the main trunk fiber, so we call them spur fibers. Let me just go to the next one. Right, so that was more of a flavor for the entire TRU in general and the work that's been done previously. So W3 is the work that we have recently finished, and it's gone out for approval. So a bit of background on the area itself. So it's the works between Huddersfield and Ravensthorpe. It's the W3 project area. But in what happened in Grip 4 is we have W2B as a subsection of W2, which is from Moseley to Huddersfield. And then we had W3 from Huddersfield to Ravensthorpe. These were two separate projects during Grip 4. But because of how they fringe at Huddersfield, we thought it's better to do a combined Grip 5 for both the areas. So now it includes all the way from Moseley to Ravensthorpe for W3. Do I have a question? Where's the design changed? Use existing materials. Should I take the questions later on, if that's okay?
Yeah, I think that's probably best. Yeah, I think we just said put them
Okay.
in the chat. That's okay, Tanzim.
No worries. Okay. So a bit on the fiber infrastructure for W3 area. So we've got lots of different fibers within the project area existing. There's FTN 24 fibers, as I mentioned, mainly used by telecoms, and there's two third-party fibers as well. They count up to 432, so 432 fibers in there. Now on W3, we're doing it slightly different to what we did for W1 and W2A. Mainly in the W1 and W2A area, we upgraded the existing FTN to enhanced FTNX network, which has introduced dual spurs, also introduced new network equipment to sort of increase the bandwidth and the sort of strength of the network. What's happening here is the route asset performance manager for telecoms in that region have requested that we only should have 2 operational fibers left in the ground once the project's completed, due to maintenance purposes probably. And signaling have also requested that they want to have their own standalone fiber for interlocking in the area. So that leaves us with, out of all these fibers here, we can pick one fiber to have all the telecoms services to go into and also do the upgrade works. So based on that, the complications come in is, so from Moseley FTN node, which is the connecting point all the way to Huddersfield, the existing 24 fibers, which is carrying the telecom circuits at the moment, shall be recovered, and all services we want to migrate it to the 432 fiber in the ground. Reason being that fiber is pretty much empty, and it's got it's been installed relatively new on the ground, and there's fiber joints every 2 kilometers for it, so it's easy to put in a connecting fiber. So we are migrating all the services into the 432 fiber and recovering the existing 24 fiber that's being used for telecoms. Also, all the SCADA requirements will also utilize the 432 fiber. On top of that, we are doing the upgrade works, which is enhancing the existing FTN to make it ready for ETCS. So we are adding in a redundant spur cable as well in the area. So it's a bit of additional work on top of W1 and W2A. So tried putting in this slide to say how we actually start off doing our design. So you kind of get the scope of work that we want to do, but how do we do it in the first place is, so the sort of source records that we get in before we start the design is we've got the as-built general arrangements and the straight line drawings. So straight line drawing is basically, it's if you've seen a scheme plan, it's very similar to a scheme plan or a location area plan that has all the trackside assets at the bottom, and you probably would have the cables on the top showing the existing infrastructure. So we get that on a request, and also any sort of civils drawing that's created is a general arrangement drawing showing all the everything that you see on the track side coming in for new. Could be telecoms equipment, cables, telephones, cabinets, everything on there. So anything that's existing or new going in, we get it from the straight line drawings or from the general arrangements. And then also surveys as well. So for TRU, we've got HCOM who've done all the surveys on the ground. So they provide information for all the existing infrastructure on the ground, things like pictures within the RABs. So they're relocatable equipment buildings, FTN nodes, everything in there, spare cables, patching details, all the FTN's infrastructure, everything in the ground has been surveyed by HCOM, and we've got all the survey data and the photos. And also the TENE design, which is part of Network Rail Telecoms. They do the main transmission design, for example, configuring the routers, the transmitters, everything for the patching. And also fiber allocation spreadsheets. I'll show both of them at the bottom in a bit, but they provide information on various FTN nodes, spare cables, and also how the fibers are being spliced at the moment. Also a bit about the coordination work. Obviously what we do is, so TENE, they do all the transmission design, but to facilitate that, we do all the groundworks for patching and putting in the new fibers. So there's a lot of coordination with TENE that happens during the fiber design. Also within the telecoms team, myself and two others, we did the fiber design, which then feeds back into the rack designs for the FTN nodes. So there's a bit of internal coordination there as well. And also there's a lot of staging work that's involved within W3 because the tracks come in at different times. And so there's lots of coordination with the civil team as well to check which assets comes in when. And based on that, we do a temporary design and a final design. So as I mentioned about the TENE design, so this is a piece of design that they produced at Grip4, but it kind of does most of the work that we needed from them. So anything that's proposed within the route, within the new route for routers or any sort of new interface card or transmission equipment, TENE do the design. So this is a screenshot of an overview for the W2B and W3 area. Each of these boxes are actually an FTN node where the transmissions actually happen and all the connectivity are there. So within them, as you can see, they've got different routers coming in. Some of them are existing, some of them are new. They put it in. Green stuff is the patching between FTN node to the other FTN node coming off, and the red ones obviously the new ones. So all of that details which port it should go into in each of these routers, how the network's going to communicate. All of that design is actually done by TENE. But to facilitate that, taking it, for example, from Scout Tunnel, you're going to Mosley, that connection within the ground and how that's been facilitated, how does it come in and how does that actually leave an FTN node? We do that design based on what TENE have done. So you can possibly imagine how much coordination goes in here, and a lot of change requests actually come in for that as well. If TENE do change their design a little bit, that has a massive effect on our design because we need to facilitate that later on in the ground. And another challenge we had from W3 was that because it's a staged piece of work and then the tracks come in at different time, TENE have produced an overall design, how the system's going to look at the end, whereas we need to facilitate that in a way that it shows the staged works and then the final works later on. So there's a middle step for us to do, even on top of TENE. And also fiber allocation spreadsheets. So these are provided by a Network Rail as built records. So as we said, each of these fibers have fiber cables have specific number of fibers within them. So a typical example here is this cable. So it's a screenshot of the allocation spreadsheet that we got from Network Rail. So it tells you the number of fibers you've got in there, which is this one's a 24 fiber cable. And the name of the fiber actually comes in the starting FTN node and the end FTN node. and it probably would list out all of them here. So it's got LCSC MPYA. So LCSC probably stands for Leeds City Station FTN node. It also tells you ODF stands for an optical distribution frame. So it's more like a interface point where the fiber comes and connects. So which ODF it connects to and which trays the fiber would go into, name of the cable, obviously. And then you've got the circuits actually it's carrying as well. So you can see the fiber 1's carrying FTN 1 and 2, and you've got fiber 3 and 4 carrying FTNX, so on and so forth. And then you've got some legacy circuits as well, all the way up to 24. It's pretty much empty, but it does pick up circuits on the way as it goes. They've got some terminologies here as well. So it tells you how it goes into a different FTN node and how it comes out. Also, that's the main. It also mentions the joints where the splicing actually happens. So this is what we use to do an existing splicing diagram. I'll show that in a bit. Next one being yes. So the design works that we did was obviously, as I said, we facilitate the splicing works on site. It's considering different stages of the work as well. So if you look at the right-hand side on the top right-hand side here, that's an overview of the existing W3 area. So we've got the EISG stage, which is the entry into service. And then you've got the final stage here. As you can see, it looks slightly different because we're introducing new stuff later on. But at the moment, the design actually focuses on what's on the top. And this comes in later on once this has been done on the top side. So to do that, what we do is there's a term that we use called make before break. That is when we are introducing new circuits within the fiber, we don't want to interrupt the live traffic in there. So we put in some temporary measurements so that it doesn't interrupt or has a minimal interruption in the live circuits. I'll show that in a bit in some of the designs that we did. Yep, so let me just show a few designs that we actually did here. So how do I exit this? Can everyone still see my screen?
Yes.
Okay, so this, as you can see, it's a CO1 version that we've already issued. So this is the overview for the area. So as we said, a W2B and W3 being combined together. This is the W2B area. And let me zoom in a bit. So we've got the fiber names here as well. Obviously the fiber joins. So the section between all the way from Moseley to Huddersfield, the existing 24 fibers being recovered, including all the spare cables that go into the FTN nodes. So these are different FTN nodes at different meterages. And then you can see we're introducing 2 new connecting fibers, which are spare fibers into the 432 fiber. So all of that as an overview is shown here. That's for W2B, and then this is W3 area. There's a lot of work still happening on the Leeds side, but that comes in later on. This is the EISG stage that we're focusing on at the moment. So we do that first based on all the records and GAs and everything that we have. And based on this, we do the splicing diagrams. This might look really confusing, but all it is just a replication of what we have on the spreadsheets and also add in the new stuff that we need to. So for example, this is the fiber cable itself. It's got 6 tubes in it. Each tube has 4 fiber, and they go into a FTN node, into an ODF. And then we also have tables here that explains each of these fibers, what they're used for. So this side, as you can see, it's all existing, no new works going on. Let me just scroll down, so probably just have a bit more nicer ones. Yep, so things, for example, here. So we've tried using different color codes. Let me see if I can find a better one. Apologies. I'll probably show the first one anyways. What it was. Okay, I think we're missing a legend here, but that's fine. We tried using different colors. Obviously, the fiber colors are not taken in. They're just the colors of the tubes themselves. We've tried using blue for modification. Any joints that's being modified, we've identified that as blue, or even the trays going into the ODF, and even on the tables as well. So any temporary works that we are introducing, we're introducing it in purple, so that later on will be taken off and put in somewhere else. That is to have minimum disruptions on the existing live traffic, whereas the idea is to recover the existing FTNX and replace it with the new one to facilitate ETCS. But we don't want to take it off straight away because it will disrupt the traffic. So we introduce it on a different fiber here, and then later on we'll pick it up once the recoveries have been done. So it's just staging piece of work that we do for the splicing diagrams. And then later on we've got ODF details as well for these. So that's one. Yeah. Okay. So once the connecting fibers actually go in, then the ODF layouts, we show them in details as well. So for example, we've got these ones. So we've done each and every ODFs within the entire route, how it looks like. So you can see how many, we've got 47 ODFs altogether. That's been done. And each of these patching details, they're shown in trays as well. Existing stuff shown in black, and then the new stuff coming in red. There's signaling fibers, which show that as orange because it's work done by others. And we've got tables on the side as well that shows the fiber usage, the termination, and the patching details for them. So anything in green, obviously, is the patching that comes off. So for example, we've got fibers 3 and 4, as I said, they are existing FTNX. And this details here where they connect to which router, that is coming in from TENE. And so as you can see, based on the TENE design, one of the patching needs to get recovered and needs to put in a new patching in. And any of the temporary works, that's done by us to have minimal interruption on this on the top. Anything that's in red, obviously, that's a new spur cable going in. So that's pretty much the design that we did for fiber here. So if I go back to my original slide, back again. Right, so I've tried showing some examples here. So you can see the existing stage, the temporary stage that we're doing, and then finally how this will look like. So each drawing, we had to create 2 different versions of it, keeping in mind how the temporary stage is going to work, and later on when we introduce it to the main stage, what's going to get recovered. So this is going to stay during the entry into service, whereas in the final stage, it comes off. But then in the TENE design or anyone else who's actually done the configs, they would show the overall design. Same for the optical distribution frames as well. That's in heat and lodge, one of the FTN nodes, as you can see. There's lots of stuff that will stay during the entry into service, and later on in the final stage, we will recover a lot of stuff and then do a lot of modification, but then the entire design's done. It just needs to be issued at different times. Yeah, so that's my last slide. We've not actually got any pictures, or that the work's not been done yet for W3, but these are some of the pictures we have from the works that's been already commissioned for W1 area. Yeah, some of the FTN node, the racks have gone in, the mainframe distributions as well, stacker boxes for the fiber, new trough route, and new optical distribution frames been installed. And that's TRU in a nutshell, I guess.
Thank you, Tanzim. It might be worth just going, that's a red slide, isn't it? Maybe go back to maybe some of the images of what you showed at the end there. Might be useful for us to talk around. Now, there's some questions in the chat, but I welcome anyone to, I might be asking some silly questions as we go through this, so just bear with me on that one. So first of all, there's one from Callum Burns who's asking, where has the design challenge scope? Have you reused existing materials or tried to be sustainable from a telecoms perspective?
That's a really good question, actually, because that's where the temporary stages come in. So we tried doing that, keeping as much as reusing as much as existing stuff as possible. So we tried showing that as a modification in our design rather than taking it off. There has been a lot of cases where we had it would have been much simpler to actually install a new fiber joint, for example, and then take off the existing one. But then we did a whole workshop just sitting down within the W2B area. How can we reduce the new number of joints and then use the existing joints to take in the spur cables? So we had to go through a few standards and stuff And then what we came up with is we can introduce another spur within an existing joint. It can go up to 2 kilometers. So there's been lots of ways, but that is a good example I can give on that we've tried being sustainable and using minimal stuff underground as possible.
Okay, then there's a question from Carl Hallen. Is the TRU Ops Telecom team coordinating any GSMR stroke network enhancement in prep for ETCS?
They are, yes. Not really sure if Ajaz is in the call, but
I think
yes,
Wayne has
yeah,
provided a bit of a response to that. If you can
Yeah, I
see
think
that.
Wayne's just answered it. Thanks.
Yeah, okay. Yeah.
I don't know if it's just worth explaining that to everyone. So, Carl, the transmission and radio network has been uplifted to provide coverage, capacity, and availability to support ECTS.
ETCS, yeah. So it's a separate team that's been involved in this, doing the ETCS works and the GSMR. But yeah, there are coordinations going on with them.
Carl's got another question. I don't know if he's on mute. You can ask the question if you want, Carl, or I'll just read it out.
Yeah, just interesting to see how TRU are approaching. Obviously, we're increasing the amount of SCADA for the power systems management control, and there seems to be two sort of flavors going on nationally. One is to place the SCADA fibers in with the HV cable, and another one is making their own routes. I'm just interested in sort of like how TRU are doing, whether they're placing these SCADA fibers. Some of them are running on FTN, some of them are, most of them are separate, and whether they're just putting the cables in the cable trough with the FTN cables.
I think they go in with the FTN cables. As far as I've seen on the new designs, all the HV cable routes are separate to the SNT cable routes.
Yeah.
And SCADA actually utilizes the SNT cable routes within the area.
Oh, okay.
Yeah.
All right. So you haven't seen them being thrown in with HV cables at all?
No. Not
Okay.
so far, so yes.
Okay. Cool. Thanks very much.
No worries.
Nothing's been thrown in on TRU. Michael Cunningham's just put a quick one in there. Might be an obvious one, but could you run through what an FTN node does and where the other disciplines plug into the FTN?
Yeah, so let me see if I've got something here on top. So FTN node is basically, as I said, FTN's the Network Rails private network, which is the fixed telecoms network they use. Each of these FTN nodes actually are like a distribution hub, as you can say, from different areas. So for example, say I've got here a few FTN nodes, but that's just showing the routers. Don't really have a proper diagram, but what it is you've got different areas being covered by different FTN nodes. So you've got loads of circuits within that area that would actually use the fiber within the area to go in, where we actually facilitate that to go into a distribution frame, which is an ODF. Think of it like a socket. And then you've got the other side of the socket that comes and connects to the routers for distribution. And it takes it to wherever it needs to go, either to a route control center or a different FTN node, or maybe it's going to a mast somewhere. So it's more like a distribution hub. And there's lots of stuff, lots of other stuff going on as well. As I showed, there's a few racks that I've shown here. Some of these racks are being installed by others. Some of them have the telecoms equipments within them. A lot of transmission equipment go in there, but the idea is it acts as a hub for distribution.
Okay, yeah, thanks for that. Yeah. And is that distribution of stuff internal to the railway? There's not stuff coming external off the boundary?
No.
Okay. Yeah, thank you.
Thank you, Tanzim. Just a few more questions coming in. So, Mohammed Abdin, have we covered connections to both SFCs at Ravensthorpe? I'm probably going to embarrass myself again. SFCs?
Not sure what the SFCs stand for.
Okay.
Yeah, I think
we
frequency converter.
Exactly. So we're going to install 2 static frequency converters at Ravensthorpe. So I wonder if we have covered any connections for them.
Can't really remember on top of my head, but if it is covered, it's covered by the TENE design because they do all the transmission design for it. So any sort of new circuits that coming in, they put it on, they request it for Kramer and then get all the details on there, and we take it from their design. So I'm hoping they did, but I can't really remember on top of my head. Apologies.
Yeah, they are probably brand new sites. I think one of the Gledholt and the Ravensthorpe in W3 area. So I just want to make sure, so I just want to make sure that they're brand new sites. They're probably going to closest FTN node where they can be connected, when we come to that stage.
Yeah. That should be covered by the TENE design, hopefully. And then if it is, it's going to be reflected on the telecoms design as well to facilitate that.
Yeah, thank you, mate. Appreciate it.
Right, okay, got another question from Andrew Reed, who's just a query on the spec of the fibre, initial rollout of FTNNU's super armoured cable, surface running in places. This looks like a non-armoured, so requiring cable route, any bend radius issues, etc., or other issues with sharing with S&T?
Don't think there are, because we've got the way we've designed is if we have allocated enough slack within the cables as well in the stacker boxes if there's new cables going in, and all of these are standard PE, and some of them are dissect cables going in, but I've not seen any issues so far with bend radiuses. That's been discussed already within the preliminary stages, I think, when we did the cable route design.
Okay, one from Andrew Craven. In the photos you mentioned stacker boxes. Are these the jointing and additional cable storage? And why are these not in the location case?
Because they go in the ground. That's where the fiber joints actually go in. So civils would actually design location for the stacker boxes, and we pick it up from the general arrangement drawings where they go in. That's where if I just go back to that picture where it is, it's on the ground and it is where the joint goes in, and from there, it's closer to the trough root, and then that's inside of the stacker box as well as shown the looped fiber in there, as you can see. It goes in and the joint.
How does that work with easy maintenance? And you're lifting up a lid, you're getting inside a confined space, or is it just not a consideration? Or
in terms of maintenance, I'm not really sure on that because
it's not really classed as a confined space. Basically, they're only about 600 deep. You pull the whole loops out together, and you normally have like a little tent set up and a workbench, and you take the joint onto the workbench to work on it.
Okay. That makes sense. All right, thank you.
Thank you, HS.
Thank you. There's another question from Andrew about how to manage the security of the fibre, e.g. vandalism, cable route fires, given the critical nature of the circuits.
Well, they are in the stacker boxes, and the cables actually go through the troughs. They're well sealed, I'm guessing, within the routes. There isn't any extra protection that's given to the routes themselves, AJAS, is it? I'm not really sure.
Only if it's been identified previously where the maintainers in a BT, British Transport Police assessment, and it's a high vandal area. So normally then they have lockable lids on the trough routes, etc. Apart from that, otherwise it just goes into a normal standard route.
Okay, thank you. Carl's asking for a copy of the presentation.
Yeah, sure. I'll leave it in the chat later on.
I think what we also do, Carl, is try and upload this to YouTube, that so it can be, you've got the context to it as well, which is normally useful. I'm going to embarrass myself since there's no other questions. Just a quick one on, the importance of these cable, the telecoms and the connections, and making sure everything's going in the right location. But what on-site verification, and you talked about the survey from, is it HCOM?
Yeah.
What kind of details is that going into?
As in for the surveys?
Well, for the surveys, for example, would you find anything that isn't already kind of documented from an as-built perspective in that survey? How would that work from a survey perspective initially?
I think it changes a lot during the area because it's covering a big geographical area, and there's always some sort of works going on. What we've seen in the HCOM surveys as well is that there's a lot of discrepancies, and when they did the surveys and later on when we checked them against pictures, there's a bit of discrepancies because obviously you'll probably have one patching missing or someone's come in put in a link cable later on. So it's not always the most accurate. We get it from HCOM or anyone else has. It's always with a pinch of salt in there. But whenever we get the chance to go in and do a survey again, we do that. Based on the records we get, the as-builds kind of give you more of a specific timeline within there. So those ones from Network Rail come in, they sometimes are pretty old, to be honest. And then the surveys need to be redone because there's been some work happening recently, or that's in a year's time it's happened in the back. But yeah, it's always with a pinch of salt in the surveys, but whenever we get the chance, we do go and do the surveys ourselves to confirm things.
Okay, and just one on that verification, say if you are changing things and testing, how long does that take, just out of interest?
As in verifying if it's correct or not. It's a bit tricky one on that one. I think it doesn't take too long, to be honest, depending on if you're looking at fiber or you're looking at copper. We do need to get it checked by testers to go and see, for example, if it's a telephone we've got from HCOM, that it shows on their survey. But then when we went on site a few months later, it's still on the ground, but on the FTN nodes, it's been taken off, or we can't find it for some reason. We do have to request a bit more further investigation for it. So someone needs to go on site and check if the telephone's actually active and it's still ringing to the signaler. So there's a bit of additional steps in some cases, but most majority of the time we can sort of see it from pictures and then coordinate between the existing records we've got.
Okay. Yeah. Well, thank you, Tanzim. I don't think there's another, I think Wesley's just put a note in there about a great presentation, having to dialect. Yeah, thank you for giving that overview today. Traditionally, if you're in a room, people would do like a round of applause. I don't know if it's a virtual round of applause or mics off, but thanks again. I'll try and do a physical one, which doesn't really work, does it? There we go.